Well, before I start this, who saw this presentation last time? Right, not that many. Okay, I've got too many slides. So I'm going to go through. There's kind of two halves to this presentation. There's the rationale for what we're doing, and then there's the how we're going about doing it. So I'll spend a bit more time on the front end, and then I'll whiz through a load of slides that have got kit in it. But what I would say before I start is we're at the start of a process. This is going to go on for 3 years in building it, and what we want to hear from this community and others is how you'd like to see this shaped and why, and that will become apparent as we go through it. So an urban observatory is essentially about gathering data and understanding the dynamics in cities. As I said, Chris will send this around to everybody. I'm not going to spend time on these slides, but we're essentially, we have a capital project to build this. We don't have money to run it, so we're very interested in developing some partnerships around how we might shape this so it's sustainable in a manner that benefits the city and the stakeholders in it. We've been working on it for about 2 years now. We're part of a group called UCRIC. So 14 universities were given £138 million to build a set of laboratories across the country. Most of that money went into physical labs, and we've got one going out at the AMP focused on infrastructure innovation, which opens in November. And some of the money went into observatories, and they're going to be in Sheffield, Newcastle and Bristol. Originally, we wanted to measure everything, and we asked for about £6 million, and Biz said, no, we can't have that trade. So that's got scaled back to £1.5 million, and then on top of that, we've got, well, I'll explain, there's 2.2 million altogether for the kit for Sheffield. And essentially, we've got to spend that on sensors, middleware, data storage processing, analytics, and visualization suite. We have a community, so there's a group of us which are kind of pulling this together, which is essentially Danny, Steve and I, Prof Daniel Coker and Natalie, who make sure everything happens. We have a delivery group of people who understand this, the bread and butter of this, so we've got some software engineers, technicians, logistics people, electronics estates, Craig, who's got a foot in 2 camps. At the bottom, so there's the people who actually understand it, and then we have a fairly wide group of academics that are interested in it. And I'd like to say to the colleagues from Sheffield Hallam, very interested to talk to you if this is of any interest to you. And we're in the process of setting up an advisory panel, currently being constituted on the basis that Mark, who's here tonight, didn't know his name was actually there at the bottom. So we want a group who's going to poke at us and say, oh, you do this the right way, is it doing the right thing? This is our overall vision, and I'm going to explain this in a little more detail. We're primarily interested in energy and resource flows. So I'll explain why that's important in terms of sort of future sustainable cities. We're interested in understanding that and how it relates to sort of socio-economic outcomes. And our objective is to provide that evidence base that will do that. I'm not going to read through that. There's a load of detailed questions. What we're interested in, cause and effect, baselining, cause and effect, feedback loops are the key things in there. Now, I will spend some time on this. Now, there's a field of science called urban metabolism, which is about understanding the flow of resources, energy, and materials in cities. And all the talk that you hear about sustainable cities, a lot of it is just talk, because people don't understand these processes thoroughly. And this area of science kind of stalled a long time ago, as you can see from the state of the diagrams, because this is how people envisage cities. Stuff goes in, stuff comes out, and so on. And what we want to do is get a much better handle on these processes in cities. And if we understand this, we can then get a lot of people who are really good at optimization to figure out, for whatever indicators we're interested in, or whatever sets of indicators, how you might optimize city processes and the dynamics within them. So that's our core interest. So in order to hit the decarbonisation targets, in order to hit the targets about how we're going to thrive as a society within the carrying capacity of the planet, we need to address cities for all the reasons I'm sure all of you are aware of. We have two, as I said, energy and resource flows are two particular interests. On the energy side, this graph produced by one of our colleagues in Sheffield, which is in this document, shows this is the energy, this is electricity in this country and how much we consume, and this is gas. And to hit the decarbonisation targets, that demand needs to fit onto that network. And of course it won't. I don't care how good your air source heat pumps are, it won't fit. So we need to understand how the distribution of heat in cities and how that changes over time, how that works at a much more granular scale in order to get much better granular answers. So that's part of the question. Where do I point?
Super.
You just need to, I think you had a Skype call coming.
Oh, I did it.
You just need to click on the screen and it should be.
Aha. So the other side of that, as we start to decarbonise the energy system, the embodied energy within the city becomes more important. It's a bigger dominant element. So even once we get to the point of having zero carbon electricity, understanding resource and material flows, as I said, will become the dominant part of the conversation. So we're interested in not just the energy flows, the dynamic flows in the city. We're interested in what resources we use, what materials we use, and how that changes over time. Because this is our stock. If you look out the window, that's what we've got to deal with. As soon as we start to use stuff that's in the ground, that's raw and processed, we're increasing our burden on the planet, and we can't afford to do that at a global scale. So we're starting to map this. We're starting to think about how you do that. There's been some real breakthroughs in the last sort of 5 years on how you recognise materials. And what we'll be doing in the first instance is gathering thermal data, gathering material data, gathering energy data, and figuring out how that flows across the city. We started to play around machine learning, so I'm not a machine learning expert. We have quite a few of them. If you throw this into TensorFlow, which is Google's sort of open source machine learning platform, it will say that that is a house in the middle of the city. It will say that's a brick wall. It will say that's a painting, because the training sets haven't been developed to understand what that is. So we're starting to play around with this. We've started to get some images going, so we can recognise, you know, that's a house. It's got 4 windows. We can start to then say, well, which ones were the worst? What's it made of? How's that change over time? So we're just starting to develop this at the moment, and one of the companies we're working with that will be pursuing the Innovate third round is looking at developing the platform that will do that at city scale. Again, a lot of research questions. I won't go through that. Right, some of the nuts and bolts. So we have to spend the money in the next 3 years, and the gun went off in April. We have to have spent it all by March 2020, the capital equipment for building it. This is how the core money is split down. We've got to spend about 400 grand this year, 900 grand the year after, 600 grand, excuse me, the year after that. We've started to figure out what we're going to spend it on, and I'm going to, I'll whiz through those because I appreciate we don't run out of time. So we've started to package it up in terms of what different packages we'll do. So just to quickly whiz through the package side of it, we're going to deploy a set of research quality sensors. Now these things are expensive, so you can't put too many of them in the city, but they give you a set of reference points. So you understand at a much more granular scale than we do at the moment what's going on in the city, particularly in the first instance in terms of air quality. Oh, and I should say, yes, so we're working with the air quality guys in the council at the moment to decide where those go. We all want to overlay on top of that a set of weather stations, which will be over a larger area, and they will tell us more about other indicators, obviously temperature, airspeed, wind direction, and so on and so forth. So that will be a grid. Possibly, and what we want to do is put them in primary schools, because we think that gives us a good grid across the city, and obviously provides us the opportunity to get that data direct to kids. I'll come on to something on that in a moment. And possibly a weather radar, although when we put that on this, we thought it was 10 grand and it's 100 grand. So, so it might be, it's year 3 if we haven't come up with any better ideas for spend money on. And this is something we want to talk to you guys particularly about tonight. We've currently allocated 200 grand that we want to deploy we want to set some competitions up over the next 3 years, and we want your feedback on whether this is a good idea, to give money out, give kit out to people who've got good ideas for how that might make a difference, either as a business opportunity or as a social opportunity, that fits within the umbrella of the observatory. So we've got quite a broad umbrella, but we want to be able to hand that to you guys. So we'll be running a competition that says you come forward with good ideas, and we'll give kit out. We'll get the advisory panel, get Mark to chair it, to decide who's going to win. And one question I've got for you guys tonight is we'd like to set probably 3 themes. One that you guys think is important, one the council thinks is important, and one that we think is important. So, I had to check with Danny whether that was okay. Is that okay? Yeah. Right. So, so that's the kind of idea for that, and we're looking for multipliers. You know, we're looking for ideas that are going to multiply what we do in the direction we're going. There's obviously a backbone to this which is needed. We're just in discussion with the council, who I think, is it fair to say, we've the vendor. Can I say anything?
I probably didn't.
Right. Okay. There is a conversation going on about working with the provider of the Wi-Fi network to use the Wi-Fi network for our sensors, and we're in that conversation at the moment, which means we don't have to spend money on the infrastructure, which means we can spend more of that money on sensors and other things. Some fixed cameras, because some people are particularly interested in that. The package that's least well developed is energy monitoring in the city. How do we understand what's coming into the city? As you can see here, year 2, year 3, we're going to do that in year 3. We haven't yet bottomed that out. So on the visual side of it, so a lot of those sensors I've just shown you is all about data gathering from nodes, from sensor locations. The other side of it is understanding what Sheffield's made of and what are its kind of performance characteristics. So we're currently, we've just commissioned a pilot study to build a rig, a small rig with a visual and a thermal camera, see if we can get that stitched together properly in terms of software. We'll then add LiDAR. We'll then build something that's light enough to hang on a drone. We'll then test that on a van to see if we can run it at speed and how thick the pipe needs to be and how much processing we need in the vehicle to do it. So that gives us LiDAR, thermal and visual at high resolution. No urban observatory would be complete without a drone package. So this will be, again, allows us to do certain things that we can't from the vehicle. There's all sorts of questions around CAA, and Steve's working his way through that at the moment. So I think that will become clearer next year in terms of
18 months, yeah, we should
be able to do it. Then at the moment there's a problem. So we'll be measuring some things, because obviously we can measure a vertical column with a. So in terms of air quality, you can measure a vertical column in a way that you can't with a fixed sensor. Where we can't fly a drone, we might fly a balloon. We're having an argument about this at the moment. I like the idea of a balloon. Steve tells me that a tether's worse than a drone in terms of getting CAA agreement, so we might or might not have a balloon. We need a sensor farm so we can test the sensors, calibrate them, so we'll put that up somewhere. We'll have a van, cheap, which will allow us to test various data fusion techniques for what's going on between sensors. So we'll have an array of kit that allows us to go and take spot measurements between sensors, so we can understand which algorithms perform best. So that's a bit of a piece of kit, carry stuff around, go out to schools, tell them what we're doing, that sort of thing. And then the car. So the package I mentioned below, which had the LiDAR, visual and thermal, that's year 1 leading up to specifying a big piece of kit. So Google and others do visual and LiDAR. There's a research group at MIT that do thermal, and we're going to do all the same together in one piece of kit once we've figured out the details of how to do that through the trials. And then there's obviously putting it all together, middleware, hardware and so on and so forth. I want to get onto the diagram. Right, so, and then this is Steve's latest diagram. So Steve has a comms background, and we're working with the software engineers about how to do it. So essentially we'll have a set of inputs to the observatory, citizen science projects, and the kit we've talked about. And third-party data, we're very interested in what data can we host that others might have, because it all becomes interesting when you start to integrate it together. The observatory obviously has these components, a set of infrastructure, capture management, storage analytics and the visualization. I won't go through that in detail. This is a moving feast. We're very interested in obviously the machine learning opportunities that derive from large data sets, and we've got some work started with Siemens on using their MindSphere platform. And then I won't go through that at all,
No,
but that's kind of how it works at the moment. Right, so underway is, we've got a few smaller projects moving now. As I said, we've just started. We're waiting to hear on a couple of EPSRC proposals that went in, and we're developing a set of projects to do over the next 6 months, because if we don't get any money to make this sustainable, after 3 years, it will become a teaching tool, which is great for us, but not great for the city. So we're very keen to develop projects in collaboration with whoever's interested to make sure this thing's sustainable. So yeah, that's what we're on with at the moment. Where are all the current sensors in the city? Installing the first sensor package. Make sure the public Wi-Fi thing actually is doable and everybody's happy with that. Figuring through the workflows on some of the software side and the visualization. We've bought an 8 meter by 2.5 meter set of screens, and we've got to figure out which, we know which room it's going to go in, but that's, so we've got to get the visualization set up. Right, I've run through that really quickly because I thought we had little time, but is that okay?
Questions?
That one went, well, I think, I'm not sure which one, but that will go.
Is there a reason, sorry, technical question, is there a reason why you're using public Wi-Fi rather than LoRaWAN?
If you looked at the diagram,
Yeah.
which Martin flipped over really quickly, the LP WAN, low power WAN is in there.
Okay,
Yeah.
right.
So
Yeah, it's not
an
either
it's
or.
So we've got 802.11 there with some sensors. We've got low power one there with some
Oh, I
other
see.
sensors.
Yeah.
We're also scoping a project which we might put into EPSRC, which is to actually look at comparing different types of low power WAN and using the materials model of the buildings to create a radio propagation model for Sheffield, and then test that out when we deploy the sensors.
Okay, thank you.
Yes, sir.
Yeah, regarding your sensor data, will it be available as open data for people?
It has to be, we're a university, yes, absolutely, yes.
And follow up to about energy data, are you engaging with public contractors like Veolia or similar about the data?
Well, the first thing I want to crack is getting the university to give me its energy data. So, which we're on with. But yes, so our core problem is we've got a big pile of cash for kit and very little money for resource. So we have to be very careful about what conversation we have. So we essentially fund Steve. And some support for Steve and a software engineer, but beyond that, it's a group of us doing it. So we've got to be, so yes, we're very interested to talk to you, but we can't go, I haven't got time to go and talk to them at the moment. We've got to focus on, because if we don't spend the money, at the end of, it disappears. So we've got to crack on and build it. But if we can integrate things later, then absolutely, yeah. That's sorry, yeah.
Two things really. First of all, the data volumes you're going to have of them are massive.
Hopefully.
And, well, no, I mean massive. And also like you're going to get sucked into the GPU rather than the CPU argument, which again gets expensive. So think through how you're going to do that when the big chunks of data come. The second thing is, it seems to me there's probably a lot of companies around, such as Yorkshire Water, British Gas and what have you, that have a lot of information that would feed into your energy calculations. They know what kind of gas volumes come into the city and so on and so forth. Have you got a strategy that says who's already measuring stuff in this city and can we involve them?
So when we put the project together to put the bid in, we roughed up the work, we spoke to the DNOs, they said yes. So they measure the primary substations, they take that data live. The 800 substations in the city, they don't log it. So they've said, yes, you can get access to the primary substation data, and for the substations, yes, you can put a piece of kit on. Gas is harder because you need the gas pipe to be, you need as close to laminar flow as you can get in the gas pipe to put a clamp on it in order to measure it, or you use their data, and they don't have a lot of data. So, but they have said yes. So the reason I've said that's year 2 and 3 is we've got people that said yes, we'll help you, but there's a big difference between yes, we'll help you and actually getting it working. So it's probably one of the biggest risks on the project, but yeah, we'll be working through them. We won't be. It'll be data that they can either give us, or data where we can put kit into their facilities, data long vision.
I mean, IBM did a project in Dublin where they was looking at all different modes of transport. So their ambition was to have transportation that was designed around demand as opposed to timetable. And they will have come across a lot of the kind of technical problems you guys will come up against. It might be worth chatting with.
Yeah, we're on the, in terms of people movement and vehicle movement, we're working with a company called The Flow, and the academics that kicked it off, who look at people movement and vehicle movement. So the reason we're not spending money on that is that we know we can get hold of some of that data from other sources. But yeah, I mean, if you've got a specific person who you think can help us with, yeah, very happy to talk to them. Hang on a minute. There was, yeah, yes.
You mentioned citizen science projects. Are you tied in for hack spaces and the open data activity in Sheffield?
No. No, I don't think we are. But
Would be helpful.
yes.
They'll get your temperature sensors working for £2.
Well, that's what that money we said for competitions. We want to make sure that's will support local businesses and local and social and community, and so that's the idea there. So at the moment we've got that's just a heading, and you guys are the only subheading. So I think
Just a quickie, I was just looking at the 2 pictures on the right hand side there of your prototypes. And the future
they're off Google.
Oh, are they? Okay.
Yeah.
So,
they're just examples.
what I was going to say
images.
is that Future Cities Catapult, we had a project that deployed Bluetooth sensing into Hyde Park, which the Telegraph picked up on, but that's another story. But we were doing anonymous data gathering of Bluetooth movement. And we deployed the sensors that had been built in what we thought were military grade plastic housings. They were fantastic, but the squirrels got into them and destroyed all the sensors. So I was just going to say, make sure you choose the right housings.
Well, I think that's why we want a limited number of high quality sensors, and then the rest will be almost fire and figure. You know, the competition stuff, it will work for a while, and we know it won't.
A limited lifespan.
You know, and if it's successful, that might generate enough interest to sustain it. But we can't assume we can build this and run it for 10 years. That's one of the challenges. Yes, sir.
This is amazing, and it's going to drive a really good understanding of the problem space, in that you're going to understand a hell of a lot more about the city and its use of energy and all the flows within the space. In terms of the solution space, are you doing anything in the way of integrating and working with community infrastructure, social enterprises, that kind of thing, about looking at how behavioural change can be achieved at a city scale to respond to this?
That's a bit off. I mean, we'd love to. I mean, we have. Once we've got the data, we want to work with some communities to establish how we gather the data, because it should influence. It should influence that, but we don't have much headroom. So we're very. If people are interested in it, that can help us shape it in the right way to answer those questions, but we would need somebody to sit and help us do that.
It's kind of closing the loop, isn't it?
I accept that. Yeah, it's part of the reason to talk to you guys tonight is to say we've got like a third of an answer here, and we're kind of working away at it, but it won't achieve its what it could achieve if we don't build a bigger community around it.
My question was kind of connected, because it's really good to see where you are as well. I didn't think you were as far as you are, which is good. You've got the plan, which is great. My question's the stupid question, which is, what are the desired outcomes?
To save humanity is basically the objective is to make sure that we can, as I said, live within the current capacity of the planet. So we want to. So what I haven't said in here is what Sheffield have in AXI, Automatic Control Systems Engineering, is the best group in the country at abstract modelling. So they came top in the ref. And these guys model anything. They're doing the fruit bat brain, they do work for NASA on space weather, they do all sorts of stuff. So they're building the analytics engine, or they're starting to build the analytics engine for us. So if we can understand the flow of energy and resources in cities and how that influences indicators such as air quality and social and healthcare outcomes, we can start to understand, we can then start to simulate off the back of that. So the first thing we've got to do is build the model, validate it, and then off the back of that you can start to run simulations about how you would improve it against that set of metrics. So that's the outcomes. Sorry, that's quite broad and ethereal. Yes, Chris.
I've got two questions in a statement. Question one is two questions.
That's cheating. You now want it to
Question one is, how accurate do you think you're going to be, and how accurate do you think you're going to need to be? That's question one.
Wow. So I think my response to that is we'll be more accurate than the current solution. Because there's no one.
Low bar.
So that's one of the reasons. So one of those slides I passed over very quickly early on was about how accurate do you need to be in order to answer the questions. So that's why we want the balance of fixed sensors and some mobile, so we can answer that question. So
do you think you're going to need to be very accurate to be able to make headway on this, or do you think you need to be just in the ballpark?
we need to be, initially we need to be in the ballpark because it's not there at the moment. The bar is so low. Our challenge is, of that pot of money, how do we distribute it? Because we only have this amount of money. So we could be more granular in one area, but less granular somewhere else. We've chosen, there's a lot in there. Any one of those work packages, you could probably spend most of the money on that. So we've chosen to spread it thinly, which is a risk. But as long as we've got the key research questions sort of tagged, that's okay. But one of the questions, so the EPSRC project that we waited to hear on, the question, one of the key questions in there is exactly what you just stated about granularity of data.
So question two is,
I'm not sure that's allowable, actually. I think you can wait until some. No, pause. Just because you've organised this doesn't mean. So the chap here put his hand up.
I'll back to you.
You just wait, yeah.
Well, it strikes me as an extraordinarily ambitious project, and I think this question about accuracy and comprehensiveness is really absolutely fundamental. What would you be taking into account consumption activities within the city? For instance, if you go to shops, you buy a product which is made in Taiwan, and energy is consumed in the manufacture of that product overseas. Are you taking that into account?
So Danny and I, the research group where we run is trying to understand all those flows. So this piece of kit, this is our lab. We'll measure what we can in the city. We have within our research group, we've got two little communities. One that's interested in this, and another that's interested in using data to analyse flows of resources and materials in cities. So the other group, which aren't here tonight, are looking at across the scales in the UK. How do you break down the flow of resources and materials in cities? Because we can't answer your question by measuring these things, but by looking at some of the economic data, you can start to break that down. And if we can put the two together, we can understand our consumption-based footprint rather than our emissions-based footprint, which I think is a question. One more, and I'll come back to Chris. I feel a bit guilty for cutting him off. Yes, John.
It may be a very dumb question, but on the basis that everyone has a meter in their house for each bit of energy that they receive, is there a data set to start from or compare this to? Because every business, every outlet, every household has an energy bill. But you said earlier that the energy companies don't have very good data. Do they not have? Or is it that just data protection and you're not allowed to access it?
They don't. The smart meter. Pick me up if I'm wrong on this. They don't want us to have it because it's the commercial value of it. So if they made that data available, then all their competitors would come and offer that house a very accurate answer as to what their energy could be.
You asked the public directly for it.
I guess we could. Yeah. I guess we could. So we haven't. I mean, those sorts of questions. We've got to focus our resource on building this.
Oh, sure, yeah.
But those questions, if we can get a group together that wants to ask that question, and we can feed it into this, then brilliant. But the plan on that one at the moment is we've met with the council's, some people from the council's housing team, because we want to use the council estate in the city to train the neural networks to recognise problems in houses. And then once we're up and running with that, we wanted to go to the DNOs and the smart meter people hand in hand to say, we, the city, want data. We can anonymise it, we can do whatever you need to protect your commercial position, but we want that data to validate what's coming out of the data we gather. Sorry, Johnny. Sorry, Chris.
So I wanted to go last anyway because I've got a suggestion. The other question was, how are you bounding it? So where do you draw the line at the edge of the city? That's obviously also another complicated question, and I know you want to start small and see how far you build it out.
Well, one of the guys in our group works on what's the city boundary, and he's got, I can't remember the last count, there's 12 or 14 different definitions of a city boundary. We're going to, for the air quality sensing, we're going to focus on hotspots for the higher quality stuff, I think. That's what we're just working through at the moment. The weather station's on a kilometre grid, so we're not really interested in economic boundaries or sort of arbitrary. We're interested in boundaries driven by physical processes. So I don't think we have one. I don't have a good answer, actually.
So you don't need to have a hard boundary to measure metabolism?
Well, you do, but you can't. You define it. So we'll worry about that when we do the work later. You know, you gather the data over the physical boundary, such as it is, and then you work it out. Yeah, there's different definitions, and when you depends on what you're trying to work out, it will give you a different boundary. So my favourite is the percolation method, which is about how bits of cities sort of disappear into, so you can follow a city through the roads and through the housing outwards, and that's completely different to any other kind of arbitrary commercial.
So you're saying essentially you're going to collect as much data as you can, and then you're going to use boundaries
under certain headings, yes.
You can find out given the data sets you've got.
Yeah, under certain headings. So because otherwise there is no one answer to that. So we have to stick with physical boundaries.
So the last thing was the suggestion, because all the pizzas are arriving. So I suggest that if we go and get the pizzas and bring them over and grab another drink and have conversations about what kinds of things that we could suggest that we could run competitions about to utilise the leverage, the data you're collecting and the sensor network you're building for the research purposes that you stated in individual projects that we could collaborate on and feeding hopefully Winston some of the cash to implement.
Yeah.
So thanks very much. A round of applause for Martin. And yeah, we'll do that, and then in about 15 or 20 minutes or so, we'll carry on with the talks.
Excellent. You're quick.